Hello, welcome to the DETNET interim. It's our first of the year. We'll see if we have more. Thank you for those who are here. We're going to get started. I think we have all of our presenters here, which is great. We do not seem to have many other participants, which is less optimal. Janos and I discussed that we should continue with the presentations because the recordings will be available and we'll have that as part of our archive, and it will serve as a basis for discussion on list, even if we don't get great discussion here. We do want to say we really appreciate the presenters agreeing to come here at this Janos was talking earlier how we have many time zones, and so this is not necessarily a great time for most of you. So we appreciate you being here and contributing to the working group first and foremost. So thank you. This is a formal IETF meeting. Our note well applies. Our participants are active, the ones who are here, so we know they are familiar with this. If you are listening to the recording and you're not familiar with it, please look at the link and familiarize yourself with it, our policies. This slide governed, the previous slide governed intellectual property. This slide governs how we interact with each other. And the organization, we personally think it's very important that we all treat each other with respect and professionalism. We are pretty familiar with how to run MeetEcho and being remote at this point. Keep your mic off. I am not using a headset. I think it works okay either way. The IETF guidance is, though, please use a headset. We're using MeetEcho. We have joint note-taking. The note-taking link is in the chat just to make it a little easier. We already have pre-populated it with the outline. Our intent is that when we get to the wrap-up, we will capture the notes in the notepad, and that will talk about where we go next. The agenda has been set for a little while. Besides the chairs, we have 3 presenters to go through 5 different topics and drafts. I think this is an important slide for those here as well as those listening to the recording. We are trying to identify a small number of working group defined solutions. We are expecting more than one. We are not expecting, we probably don't expect to see as many as there are drafts at the moment. The intent is to use categories that are coming out of our working group document, the taxonomy, and that we really do want to move towards working group adoption. To help facilitate that, we hope that we request that the individual authors update their documents to reference which category they see themselves falling into. Of course, we'll discuss that as a group as part of adoption. And we're really looking to only have one working group document, active document per category. You'll notice the word active. That's there intentionally because we may find that we start with one in a category and then the working group decides we're not so happy with it, and so we will adopt another one. At the time we adopt another one, the first one would become inactive. That's something that we'll manage if we end up having collision in categories. We are not requesting solutions in all categories. As always, we are contribution driven and we are also consensus driven. So we're expecting that there will not be consensus to have a solution in all categories. This is a teaser. At the end, we are going to summarize next steps. We only need a few minutes for that. And that's my last slide. We're going to now hand off to Xiaofu. Let me see if I can do this. And if I want to give you control, you should now have slide control. Thank you.
Yes, thank you. I see it. Can you hear me?
Yes, perfectly.
Okay. Hello. This is Xiaofu Pan from ZT. Now I will present the deadline-based forwarding mechanism. So, let's review the overview of the EDF scheduling mechanism. The target of EDF mechanism is to assign different flows to different delay levels to ensure scheduling before the deadline based on the quantified delay levels resource in the network. So the following picture briefly describes the key behaviors of EDF. First, for each packet of each flow arrived at the node, a deadline is assigned to the packet, which equals to the arrival time plus the planned residence time and plus the latency deviation. So secondly, the packet will be inserted to the corresponding position of the queue based on its deadline. The queue may be a sorted queue or an approximate queue, for example, a rotation queue, or someone called a calendar queue. And thirdly, all eligible arrivals must meet the schedulability conditions, which is the mathematical foundation for defining multiple delay levels and the related resources. So fourthly, when the actual arrivals violates the eligible arrivals, it will take a receiving or latency compensation, and the late option is recommended. So this slide explains the functional characteristics of EDF mechanism. The latest version of draft taxonomy defined the function category of periodicity, traffic granularity, and time bounds, respectively. EDF is non-periodic since the scheduling power of EDF is measured over an arbitrarily long non-repetitive time duration. And EDF is class level. Flows can be grouped by similar delay level provided in the network. And the packets will be provided EDF service based on the delay level without checking flow identification. And EDF is at least right bounded because the deadline by definition is the maximum time bound. So EDF with in-time mode is right bounded. And while EDF with on-time mode, due to further limiting the minimum time bound, is bounded. The latest version of draft taxonomy also provided at most 7 suitable categories for DETNET. According to the analysis of functional characteristics of EDF mechanism, EDF with in-time mode will map to right-bounded category defined in the section 6.1. And EDF with on-time mode will map to class level non-periodic bounded category defined in section 6.5. So this is a briefly give the mapping information of category. So the authors will appreciate any questions, comments, and supplements to the EDF and the taxonomy mapping result. We will think well with the plan of WG data plan solutions or options. Thanks.
Do we have any questions? Janu.
Hello, Xiaofu. Thanks for the presentation. Could you go back to the page 2, maybe?
Okay.
Yeah, here the bullet 4. I mean the number 4.
Mm.
When actual arrivals violate.
Mm.
Could you elaborate on what is the violation here, and how can we provide that the arrival cannot be violated?
The actual arrivals maybe often violates the eligible arrival. For example, there may be some queue package and the upstream node, and we send the bus accumulation to the downstream nodes. So, on the downstream nodes, it will find that the actual arrivals will violate the eligible arrivals. So, it will take a receiving or latency compensation to address this problem. I think that this issue we have discussed many times.
Right.
In the
Yes.
values.
Yeah. So the burst accumulation happens all the time in every downstream node, and
Yeah.
it is kind of very hard to expect, very hard to characterize how much burst can be accumulated. So if that is the case, violation of the arrival pattern is not the flow's fault. It's network's fault. But I think that the penalty goes to each flow. And can you say that this policy still guarantees the end-to-end latency?
Sure, because for example, if we take receiving or latency compensation, the packet interval of each flow will be maintained as the same as that pattern and the flow entries node. So it will meet the function constraints for that flow. So if all flows will meet the uh, function constraints of the way so the scalability condition will be met on each node. So it is not a problem.
Yeah, to me, I understand like this. The the arrival function in the downstream node can be obtained somehow, but it's very complicated. And in dynamic
Mm,
network condition, can we still do that calculation?
No, it
Let's
will not
discuss it
calculate.
later, maybe. Yeah, yeah.
Yeah,
Okay,
I
thank
will.
you.
Thank you. Okay. So the time is limited. I will briefly answer this question. Uh, on the downstream node, the data plane will know that calculate the dynamic condition. It will just for example, based on the latency compensation, it will recover the packet interval that is similar as the flow entries node. So okay, we will discuss on the main list later. Thank you.
Okay, thank you very much. Appreciate the presentation and the discussion. One of the things that's going to be very important is to make sure we have agreement on categorization. so that as part of an adoption poll, we can make sure that the working group is on the same page of basically what other solutions we might conflict with. And with that, I think you were up again.
Okay, thank you. So I will continue to present the TGF mechanism. Can you give me the control? I've lost.
Do you have them?
I have not.
Let me try again.
I cannot see the control, but okay, I see it. Thank you.
Yeah, that was weird. It like went over and then it flashed, and I guess it came back. I don't know what happened.
Maybe the problem is that I tried to give it to you at the same time.
Oh, funny. Race condition. Nice.
Okay, so this is a TGF overview. So let's also review the overview of TGF scheduling mechanism. The target of TGF is to let the flow periodically access designated time slots in the orchestration period and achieve flow interleaving based on the time slot allocation. The following picture briefly describes the key behaviors of TGF. First, it will detect and set up the base time slot mapping relationship between the adjacent nodes in the network. And this mapping relationship is generally constant if the topology is stable. And secondly, set up the forwarding time slot mapping relationship for each flow. This mapping relationship is actually a slot stack composed of multiple hop outgoing time slots. And thirdly, insert packets to the queue based on the outgoing time slot ID of that packet. So these slides explain the functional characteristics of TGF mechanism. The latest version of draft taxonomy defined the functional category of PLVDCD, traffic granularity, and time bounds. TGF is periodic since there is an orchestration period containing multiple time slots, and a flow is assigned repeatedly to a particular set of time slots in that orchestration period. And the TGF is flow level since a time slot and the corresponding FTM that is a forwarding time slot mapping is assigned per flow for interleaving. FTM is flow specific, which represents the incoming and outgoing time slot mapping relationship. And the TGF extends TAS single scheduling traffic queue to multiple slot queues, which can be allocated to each flow. And the TGF is bounded because the transmission combination time is within the outgoing time slot. That is after the beginning of the time slot and before the end of that time slot. So these slides give the mapping result. According to the 7 suitable categories for DETNET defined in the draft taxonomy in the latest version. And according to the analysis of functional characteristics of TGF mechanism, TGF will map to flow level periodic bounded category defined in the section 6.2. So please let us know if there is any questions and comments and supplements to the TGF mechanism and the mapping result of taxonomy. we will work single well with the plan of WG data plane solutions or options. Thank you. Any questions?
Hello. Hello,
Hello.
Xiaofu. Thanks for the presentation. It's again me. I have it's not a question, just a comment. To me, the scalability is the big issue here in the networking group. And assigning a time slot to each flow is a very good idea, but I wonder if how much it is scalable. I mean, have you considered about the complexity of assigning time slot to each flow in a large scale network? Thank you.
Yeah, this is a good question. So the complexity we in the controller plane to assign a time slot to each flow. So we will address this problem on the separate document. In fact, this document is also submitted. Well, I think we can continue to address this problem under the document. Thank you.
Okay, I think you've finished, correct? So we're ready to move on. Any other comments you want to make before we move on? Xiaofu?
I have no further comments. Thank you.
Okay. All right, great. Thank you. So with that, we're going to move on to the next. So number 4 is Jinu. You can come into queue.
Thank you. Yeah, I got the control. Thank you. Hello, everyone. I'm Jinu Zhang. Okay, next. Yeah, history of C-score. It has been presented since 2022, but anyhow, it has been separated to an independent draft from 2023. It has been through intensive debate, discussions up until IETF 109, but after that, it has been quite stable. A category of C-score according to the taxonomy draft. The taxonomy draft categorizes the solutions into many different subcategories, but we have been successful to devise, to come up with 7 suitable, so-called suitable categories. So they are numbered here. And according to this taxonomy, this C-score belongs to the first category. It is flow level, rate-based, unbounded solution. Here, the time bounds is the latest or earliest time a packet is allowed to be serviced. So term allowed is very important. I will describe about the operation of C-score briefly. There is a situation here. There are 3 flows arrive from input ports from at the same service rate, at the same link capacities, and 2 of them are bursty. The blue and the orange flows are bursty, and the green one is rather stable, non-bursty. So how will these packets be scheduled according to the C-score? Here, we allocate an imaginary dedicated link to each flow, but the link capacity are different, and the link capacity of the imaginary link equals to the flow service rate. So these three flows have different service rate. The blue one receives the small service rate, while the green one has the large service rate. So as you can see, the three packets from the blue flow is kind of elongated according to its service rate, because service rate is small. Its service time becomes larger. Service completion times becomes larger. Sorry. And it is pointed by the arrow, and this is the service completion time of first blue packet in that imaginary link, and it is called finish time of that packet. And as you can see in the next slide, all these packets will be served in the ascending order of this finish time. And this is the actual service schedule of the packets in the output port. The result of such a fair queuing mechanism is that the flows get their fair shares of capacity fairly, while not wasting remaining link capacity. And as you can see in the example of the green flow, the packets are isolated. The green flow is isolated from the bursty flows. And another advantage here is that you can see that burst of each flow is quite mitigated. They are evenly distributed here. So this is the idea of the fair queuing. And the stateless fair queuing, the syscore, extend this idea even further. The entrance node keeps the flow state, but the core node don't have to maintain such a flow state. The core node simply updates metadata, the finish time, and then serve the packets in ascending order of these updated finish time. So the syscore has such an advantages. It has simple admission control procedure, which only depends on the service rate of each flow. The sum of the service rate of the flows should not exceed the link capacity, and that's it. That is the admission control condition. And the syscore has an axon flow isolation, as you just saw. Once admitted, a flow is not affected by any other flow's fluctuations. For example, their joins, leaves, or mel behaviors. And we even have the flexibility to adjust end-to-end latency bound by setting the assigned service rate of flows. And finally, it has an excellent statistical performance. I mean, the average performance, due to its work-conserving nature. I think this is important because it keeps the average buffer occupancy low, so that any other best effort traffic can be served better by this principle. This is the complexity of the syscore. The first, the end-to-end jitter bound is same with the latency bound currently, because we do not control jitter yet. But I will present to you in the future meetings that even this jitter can becomes very low by some other mechanism other than syscore. And it has data plane complexity that it needs a priority queue, or so-called sorted queue. Its complexity is about twice of the FIFO. That is the only data plane complexity here. And control plane complexity is not that big, because as I just mentioned, admission control is necessary, but that admission criteria is very simple. No more control procedure is necessary, such as slot scheduling. These are not necessary here. And additionally, I will describe about how this syscore conforms to the scaling requirement specified in this document. In this scaling document, we have 8 functional requirements for scaling. As you can see, I will go into the detail. You can take a look. There are 8 of them. But somehow we can reorganize these requirements into 3 groups, I think. The first group is to overcome the inflexibility of synchronization and cyclic operation. So these number 1 to 3 requirements are due to the synchronization and cyclic operation. And there are other requirements due to large network size and high utilization. For example, number 4 and 7 are such requirements. They require to overcome the complexity due to large-scale network. The third group is about the network dynamicity. For example, link failure, topology changes, and so-called flow fluctuation. I've been discussed with Pan about this issue, but I think the flow fluctuation means both flows join and leave and flow burst. And there are other issues such as multi-domain issues. This also belongs to the network dynamicity, I think. So how the syscore meets these requirements? For the first group of inflexibility, because syscore does not need synchronization nor cyclic operation, it naturally overcomes that issue. And the second group, the complexity due to network size, it can be also mitigated, or the syscore can meet this issue because it has a nice property of the nice statistical property due to work conserving nature and very good flow isolation capabilities. And it also overcome the network dynamicity because it has simple admission control mechanism, very easy calculation of end-to-end latency bound, and so on. Yeah, I'm a little bit out of time. The draft is now stable. Thank you. Thank you, everyone.
Xiaofu, you ended a little early, so you have time for a question.
Okay, thank you, Jin, for the presentation. My question for this mechanism is that you mentioned that for the admission control, we only based on the service rate. I have a little question for that. Can you turn the page to the, for example, to the first page or the second page? I will look at the picture. Yeah, okay. No. Maybe the next one.
Next one.
Okay, this one. In this picture, for example, the blue, the red, the green, packed. I think. Do you think it is possible for the summary of what arrived the bus of blue, the green, exceed the capacity of the input buffer?
You mean so are we asking about the admission control or buffer size?
Not admission. Yeah, I think it's actually the problem and the data plane. The dynamic arrived the bust of workflows. The summary of workflows arrived at the node exceed the capacity of the input buffer.
Oh, you're asking about the buffering requirements. Okay.
Yes.
Yeah. Yeah, that's a okay. So there are burst accumulation, of course, and however the amount of the burst accumulation or the maximum size of the burst accumulation is also limited, is also bounded, and
Yes, I think
usually
so.
usually the buffer space um, is not that limited in modern switch or modern routers, other than a very restricted environment, such as in-vehicle network. But I think that the networking group's scope is above that, and I don't think the buffer space is a limiting factor here.
While I really appreciate the great presentation and discussion, to be fair to Jan Scholl, we should move to his presentation. My apologies for cutting this short and hope you'll continue it on the list.
Okay, thank you.
Thank you.
Can you hear me?
Yes.
My name is Yuan Yu from 3. I will introduce the category and operation procedure and capability analysis and user case of the on-time forwarding with Hyperq. First of category of on-time forwarding. Since the on-time forwarding with Hyperq method control the transmission of packet based on the noise delay upper and low bound set for the each flow at the node. So according to the taxonomy draft, the suitable category of the method is number 4, flow level non-periodic bounded category. According to the user requirement, the end-to-end variable delay upper and low bound, excluding the fixed delay, such as link propagation delay, set as the node delay upper and low bound at each node along the path. And from the ingress edge node to egress node, when a packet arrives at the time t, each node calculate the minimum departure time as the arrival time t plus the node delay low bound minus their mean, and maximum departure time as the arrival time t plus node delay upper bound minus their max. Here, their mean and their max refer the minimum and maximum time required to the packet to completely exit to the node after it leave the queue. The packet after calculated the minimum departure time and maximum departure time, the packet enqueued in the Hyperq in the ascending order of the nominal departure time, which is the midpoint between the minimum and maximum departure time. And when a minimum departure time of the packet in head of a queue has reached or passed the current time, the packet could be dequeued from queue. And end-to-end the variable delay upper and low bound are inserted into the packet header at the ingress edge node as a remaining delay upper and low bound. And when a packet leaves the node, the node subtract the residence time from the both of the remaining upper and low delay bound. And last node, edge egress edge node determine the minimum departure time and maximum departure time of the packet based on the subtracted remaining delay upper and low bound. So on-time forwarding with PyForQ method can adjust the end-to-end maximum and minimum delay according to the user requirement, and can be applied to the multi-domain and multi-path such as P2MP path. But on-time forwarding method require per flow automation control process. This method need to check whether the burst some of the burst at all nodes along the path is less than the difference between the low and upper node delay bound. This is burden of this method. And on-time forwarding also require the per flow node upper and low bound information at the node and remaining upper and low bound at including to the packet header. This is where use case of the on-time method. This method can be applied to the specific use case where the multiple user collaborate with the time-critical service over the multi-path network. Each user needs to have the same latency and same jitter with the different path length and number of hop. Adjust controller calculate each path low node delay upper and low bound match to the end-to-end delays matching to every user. So as a result, end station buffering is effectively replaced by the network delay matching. Thank you. Do you have any question?
Well, thank you for putting the category right up front. Appreciate that. Thank you for the presentation. And you're up next, so we'll just move straight on to yours. Next one, and this is actually the last slot before I wrap
up. This is second on-time method called N-score, non-more-conserving state co-fair queuing, stateless co-fair queuing. N-score at the concept of the elizable time to C-score to ensure the minimum delay. So since the N-score transmit the packet only after the eligible time, which is determined by the rate of each flow at the node. So according to the taxonomy draft, suitable category of the N score is the number 2, flow level rate based left bounded category. In N score, the entrance node manages the previous packet's finish time and obtain the current packet's eligible time and finish time by comparing it with the arrival time, and transmit the packet that after the eligible time in ascending order of the finish time. Therefore, the packet by packet service period within the flow does not overlap, and then the maximum and minimum delay can be guaranteed to the constant. NSCO operate at the both entrance node and core node. Entrance node manages per flow state, including the previous packet finish time and service rate. And entrance node obtain the eligible time by the maximum of the previous packet finish time and the current packet arrival time. And finish time by the eligible finish time is obtained by eligible time plus the plus that the packet length divided by service rate, and mark the eligible time and finish time for the next node to the packet header and transmit the packet that after the eligible time in ascending order of the finish time. Ascending core node, no per flow state is management. Only it's simply obtain the eligible time and finish time from the packet header and update to eligible time and finish time by delay factor at adding by delay factor, and transmit the packet is same with the entrance node method. Transmit the packet at after the eligible time and ascending order of their finish time, include at the queue. The N-score has a simple automation control process. Only compare the service rate with the link capability, and has a flexibility to adjust end-to-end latency bound by setting the assigned the service rate. Also has a fixed jitter. N-score does not require any synchronization and cyclic operation, and does not traffic periodicity. N-score can use the time deterministic service based on the more general and diverse form of the large-scale networks. It guaranteed the maximum and minimum delay bound based on the rate So it is good to use for service that come within the appropriated range the service. Thank you. Any question? Shuffle.
Thank you for the presentation. I have another question. As we know, the rate-based mechanism have a big issue for the performance latency may be very large. So for Cisco, they may get acceptable average latency due to the work concern behavior. However, however, for the N-score, it will always get the maximum performance latency on each hop. So I'm wondering about the end-to-end latency for N-score, maybe a very significant one. Thank you.
N-score and C-score maximum latency bound is the same range, same maximum latency. Only
Yes.
N-score is each packet service period is non-overlapping. So.
Yes, I agree with you that the maximum value of Cisco and the N-score are the same. My question is that, or maybe my concern is that for N-score, the end-to-end latency may be always the maximum value. It will not get a better or acceptable average end-to-end latency. Maybe we can discuss in the menu.
Yeah. Thank you. Please give your mail to discuss.
Xiaofu, if I add to that answer briefly, the N-score and C-score has the same end-to-end maximum latency. So end-to-end latencies are also guaranteed here in both mechanisms. The only difference is that N-score has less jitter because it has the concept of eligible time. However, the average latency of N-score is also large. That's the difference. Thank you.
Yes, I think so. I agree with that. Okay.
Yoshul, do you have anything else you'd like to mention?
No, it's finished presented.
Okay,
Thank you.
All right, thank you so much. So we're going to move on to our wrap up. And let's see. So I'll throw the slide up just because we have it, but the wrap up is really going to be in the minutes, in the notes. So if you take a look at the notes, you'll see that I'm about to drop in 3 observations that, oh, no, I'm not going to drop it in. Janos is dropping it in. Awesome. Thank you. So the first is that we ask, we're going to ask all authors to self-identify the category which is found in the taxonomy document with which their document is aligned. And the objective is to move forward with adoption based on the updated documents. And we're going to start the process in Madrid. if we had had larger participation in this meeting and interest in a follow-up meeting, we were hoping to sort of move the working group to the point where we could do the adoption before before Madrid. But given the lack of the lack of participation by non-authors at the moment, we think that we're going to use the presentations in Madrid as a lever to get further feedback. So we really would like to get moving on the adoptions and the standardization of the queuing solutions. Finally, just thank you all for participating. I do think this was valuable, particularly because the recording is going to be available to the whole working group, and we will summarize where we ended up and how we got there, and request that the working group review this recording. Does anyone have anyone else or anything else they'd like to add? Please, if so, jump into the queue.
So I would like to second Lou and thanks everyone for the contributions. Really much appreciated, and this is what drives the work in the working group forward. And we really would like to hear your views or comments, if any. So please just go ahead and say it. We have a few minutes left.
Well, I think we should just end by thanking people again for participating in the wide time zones and giving the 2 or 3 minutes back.
Yes, thank you. Thank you all. Maybe just to make it clear that we are not planning to have the second interim we had in mind. We think that it would not add too much to this one, but as Lou explained, we would like to really get rolling in Madrid with a wider participation from the working group and so on. Many thanks, everyone. Goodbye.
Thank you. Thank you. Bye.
Thank you. Bye-bye.